So what we just found is our central angle is 120 degrees. We want to find now as well, what is that same inscribed angle? So if we go back to this, notice this same arc from A to B. So from A to B, isn't that also intercepted by the angle right down here, this inscribed angle? Let me put this in here. So angle C intercepts B and A. Notice how that one is 60 degrees. So the central angle is 120. The inscribed angle is 60. So go back to your table, and we're going to say that when our central angle is 120, the inscribed angle would have been 60. All right. I didn't open up the big document. It should be after the homework, though. So like 150-ish. So check in the 150s or so. The big one is, ever since I've stopped doing the big one, I've had less word problems. So I've only been pulling up the pages we're doing. You find it? Okay. If we change this angle, so now let me take this A and see how the angle gets smaller and smaller and smaller. I want to get an exact angle. If there's any, took me forever to get 90 degrees earlier today. I was trying to get 100. Let's see if I can get 90 again. Cut mine here. Oh, I had it. Yeah, there we go. All right, perfect. So notice when our central angle is 90, so now let's go to our table and make our central angle a 90-degree angle. If you then look at that corresponding inscribed angle, so now A and B is intercepted by the central angle at O, as well as an inscribed angle at C. Notice how the inscribed angle is 45 degrees. So when our central angle is 90, our inscribed angle is 45. So if we go to our table, that is 45 degrees. So you're all pretty bright people. Let's say I would have gotten an inscribed or a central angle of 100 degrees. Can we kind of see what this pattern is that would compare these guys together? If this is 100, do we all agree that would then probably be 50 degrees? It's always half. Or let's say we looked at the inscribed angle. Let's say this was 40 degrees. And I then ask you what the central angle would be. Well, if that's 40, then this would have to be 80. So those relationships hold true for any central and inscribed angle that intercept the same exact arc. All right. And that's what these next couple of questions ask. If you knew the measure of the inscribed angle, how do we find the measure of the central angle? Then we would take the inscribed angle and multiply by 2. For number 3, if we knew the measure of the central angle, and that's actually what I started with. So if we knew the central angle was 120 and I want to work back to get that inscribed angle, then we just find half. It's always going to be half of the central angle, or you just divide by 2. Okay. The next thing we then want to understand, if we go to this picture here, it says use a diagram at the right to answer questions about circle A. And the first question is, if I find CB, so here is C, here is B, the little symbol over the top is really, really important because you don't necessarily need to write this down. There's a big difference between me putting CB with the arc over the top and then CB with a segment over the top. Those are two completely different ideas. This one here is the segment drawn from C to B. This one here is the arc from C to B. Okay, so the one that we are dealing with is that arc. And then the question is, what is the measure of that arc length? So what are we dealing with? So what this is based off of, and it's not something we've discussed, I assume most of you know this, but in a circle, do we know? If not, it's not hard, that a circle has 360 degrees. That's something I assume we all know. Okay, and if not, there you go. The cat's out of the bag. We all know that now. So if the full circle is 360 degrees all the way around, look at the segment from C to B. Notice how that goes straight through the middle of our circle. So this is a diameter, and a diameter cuts our circle in half. So if there are 360 degrees total in the circle, and that arc is getting cut in half by the diameter, then doesn't the arc itself make up 1/2 the degree measure of that circle? So that yellow arc is 180 degrees. All right, so that's what we get for that. When you go to number 5, it's now asking you to find the degree measure of the angle formed between C to A to B. So if I go up there and do that, so here's C, here is A, here is B. So the angle goes from C to A to B. Isn't angle CAB then, isn't that really just a straight line? The angle CAB? That then brings up an old idea that everybody knew pretty well. Doesn't a straight angle always have a degree measure of 180 degrees? So it is a straight angle. We know that the degree measure of this angle right here is 180 degrees. What we then want to understand as well, isn't this a central angle? Isn't this angle formed by the center of our circle? Because notice how the central angle, 180, just so happens to have the exact same degree measure of the intercepted arc. So what we want to understand about that is, so we'll add this to number 5, is your central angle measure, so whatever that central angle measure will be equal to whatever the intercepted arc's degree measure is. All right, so if the central angle is, I'll draw a quick one here. I'm going to add some here in a second, so you don't have to draw this one in. But if I tell you that this arc has a degree measure, let's say that's 75 degrees, then we know this central angle is also 75 degrees. They are always the same degree measure, the central angle with the arc. Okay. All right, number 6, let's see what we remember from the previous page. Now go to angle CDB. So let me pull the picture back up. Here is angle CDB. It's what we did on that previous page. If I know that my central angle is 180, then if we go back to our table, let me actually just throw this into the table because then it's probably easiest. If our central angle is 180 degrees, and I then ask you for the inscribed angle, all of these are always 1/2. So if we knew our central angle was 180, then that inscribed angle that I'm asking you about, the CDB angle right here, would have to be 90 degrees. Okay. So what we want to understand here is an inscribed angle is 1/2 of the intercepted arc. And then add a quick little example once we have that. And I'll show you the example here in a minute. So write that down. And then here's going to be our example. If I draw in a circle, And then let's say I draw an inscribed angle. So I'll do it here to here. And I tell you that this angle, or let's do the arc. If I tell you that this arc length is 100 degrees, that's how much of the 360 around the circle we have, then that inscribed angle is 1/2 of the intercepted arc. So this is the inscribed angle that creates this arc. This has to be a 50-degree angle. All right, so the central angle is the same as the intercepted arc. The inscribed angle is 1/2. Okay. All right, so I'm just going to add 2 or 3 here just so we understand this. So add a number 8. I'm going to use my fancy ink to shape that I forgot about. So let me draw my circle. And then let's draw in a problem that looks like this. So here, here, here. Let me change that just a little bit. And what I'm going to give you, let me label these with some letters, A, B, C, and then D. And what I'm going to tell you is that the arc drawn from A to D is equal to 60 degrees. And what I want you to find is the measure of angle ACD and the measure of angle ABD. Okay. So process all of that. If you want to draw it out, feel free. You can just look at the paper or my screen as well. So if the arc length is 60, tell me what the central angle would be. So that would be this guy. This is our central angle with C as the vertex. And then this would be our inscribed angle. All right, so if I do this one first, let me do these in different colors actually. So if I do this one first, ACD, that's this angle right here. That's our central angle. So what we have written above, so it's just testing us on this idea here. Your central angle is equal to the degree measure of your intercepted arc. So if I want to know what's the degree measure of this angle here, then if this arc has a degree measure of 60 degrees, then the central angle should be the exact same thing. All right. The next one, ABD, so that's this angle here. That's an inscribed angle. And from our table above, isn't that always 1/2 of the arc or 1/2 of the central angle? That would have to be a 30-degree angle. Okay, easy enough. All right, then one more. So number 9, let me use my fancy ink to shape tool. So there's that. And let's do an angle here, 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 here. And I'll say this is 60. And this is angle A, and then B, C. So find 2 things for me. What is the degree measure of arc BC? And what is the measure of angle BAC? All right, so do those real quick. Well, it's good for you to join us, Andre. Nice to hear from you and see you, kind of. We are on, what page was it? 156? I don't know what page it was, but we are just in the next set of notes. So it should look like this here. It says 7.2 day 1. So from yesterday, we had notes, and then there was an assignment that followed those notes. We should be on that next set of notes after that homework. Now, there's a bunch of pages, and we're on now, I think, the 4th page of these notes. So you're looking, and then I'm adding these. So you're looking for problems that look like this. 6 says the measure of CBDB. 7, you're looking for that page. Anybody have that page number to help Andre out here? I'm only pulling up the smaller version because my computer doesn't like the 200-word document. It freezes on it all the time. We know what page we're on. 156. Go to page 156, Andre. Hey. Yep, that's exactly what I was going to say. If you go to our class, we're recording it. I'll upload it right here underneath the module 7 stuff, okay? Yep. All right, so what we should have here then, this is your inscribed angle. I'm asking you for the arc degree measure, so that's this right here. If the inscribed angle is 60 degrees, what do we think for the degree measure of the arc? What should that be? Okay, good. My chat's not popping up for some reason. Thank you. Last period either. Yeah, that has to be a 120 degree arc. So we're basically 1/3 of the circle, 120 of the 360. And then the last one is the central angle BAC. So here's the angle drawn between BAC. And then now it's really either or. Do we understand how this relates to this arc? Or we can also understand how the central angle relates to the inscribed angle. Either way, what do we think that has to be? Either in the chat. Although my chat's not working for some reason. We'll pull that up. All right, what does that have to be? Little brave souls. Make a quiz out of this real quick. All right, do we all agree with Dahlia? Some. All right, real quick. This is our central angle, right? It's drawn at the center. All right, so it's a central angle. So if we go back up here, your central angle measure, which is what we're looking for right now, will equal the intercepted arc degree measure. So if we go back to that problem, this is our central angle. Look at the arc that it intersects. So when I draw this out, here's an intersection with the circle. Here's the other one. So if this arc is 120 degrees, what that rule is, these should have the same degree measure. Okay, so that one would be 120 degrees. So one is half, one is the same. We just want to make sure that we're keeping those straight, and then know which one is each is called. Is it a central or is it an inscribed? And then know if it's half or double or the same. Okay. All right. Well, thanks for those answers. Thank you, Dahlia. All right. So with that, I'm not going to give homework on this. The homework is a little harder than what we were able to get through today. So we'll probably do a little bit of the homework tomorrow. Be ready for one of these little questions again as a little quiz, either at the beginning of class or the end of class tomorrow. That's again how I'm going to kind of do little quizzes for the next 6 or 7 days of class. So we don't eat up a whole period of it. But for tonight, nothing is due unless you didn't get yesterday's homework done and uploaded. If you haven't, make sure that gets done by midnight. All right. But other than that, we're done. You guys can enjoy the rest of the day, and we'll see you tomorrow. All right. See ya.